Hello and welcome to today's webinar, Simulation within Inventor Professional, Frame Analysis. This webinar is brought to you by Live Lab Learning, which is a part of Academic Corp, a wholly owned applied software company created to provide world-class training. My name is Patrick Musa and I'm delighted to be your moderator today. Throughout our presentation, we encourage you to interact with us by typing in questions and comments using the question pane on the right-hand side of your screen. We will be answering questions at the end of the presentation, so do not hesitate to ask. This webinar is also being recorded and will be available to you online through our YouTube channel. Please take note of our upcoming events. The next one we have coming up on the 24th of March is with Panzera and the benefits of centralized storage to increase productivity. We have one on the 14th of April, Get It Right the First Time, Simulation. And the last one we currently have on the docket at this moment is Benefits of Autodesk Accounts, and that's on April 28th. Of course, my contact information is at the bottom there, so feel free to reach out to me if you have any questions. Today's presenter is Dennis Howell. He is our Senior Application Specialist. He has been with us for over 25 years and describes himself as an overall general nerd. Please join me in welcoming today's speaker, Dennis Howell. Dennis, the floor is yours.
All right, thank you. Whoops, let me get back out of this. Give me just a second here, folks. Welcome, greetings. All right, here we are. Now we're back in Inventor, and this is what y'all all came to see here. Now, today's session we're going to be covering frame analysis. Primarily, we're going to be focusing on that. But to actually model a frame in Inventor, the best tool for it is the design accelerator called the frame generator. And so it's a little bit needful to kind of go back and kind of set the stage of what the analysis is looking for and what the analysis is we're going to be working with. Now, generally, when you go to start building a frame that you might eventually need to analyze, maybe as a structural frame for a building, as well as structural framing for possibly housing of machinery, and then, of course, could be just a simple support for a motor, as well as maybe some sort of robotics support. It kind of helps to go ahead, and as you can see up on my screen, I've got just a basic shape to represent what I call the outside edges of the frame that I want to put together and work with. What that does, it gives you kind of a skeleton to start working with, and I actually refer to it as my base skeleton up here when I start doing my initial. Now, what this is just a simple solid model. You'll notice I'm in an assembly at this point, and if I double-click on that one part, it's just various solids. So I generated the general shapes here as individual solids instead of letting them be generated all as one piece, because I wanted to keep my lines that you can see represented by the box at the bottom here, and then of course the next solid representing this angled part, and then my final part is a bridge, a little bit of a bridge area there. And I've added into it, just kind of depending on where I was, and in this particular one anyway, some line work representing more of a cantilever or an overhang. Now, again, I set this part, once I do it, I set it as something clear, and it's also, it being a part, when you create it, you want to set its BOM as a reference part rather than a normal part, and that way it will not be referenced as far as the BOM goes, bill of materials, nor as will not add to the overall weight of the assembly once you go back and you start looking at the eye properties and setting those parts up as well. Now, when I come back to my my top level in the assembly now, the frame generator is right up here in your Design tab. And just a note here, there's quite a few other little tools up here for use with the frame generator as far as trimming and mitering and notching. I'll show you a little bit of that, but when you're doing your initial design of a frame, it's not necessary to go ahead and do all that cleanup. I actually recommend not doing the cleanup until you're happy with the design. Once you're happy with the design, then you're good to go. And then take that extra time to go in and miter and trim and notch as you see fit. But a lot of times you might be changing the design in lieu of what your results might be showing up within the simulation for your stresses and all. And so rather than go through doing all that cleanup, I prefer not to clean it up until after I'm happy with the overall design. Another thing that's nice about using kind of this clear box over here to use it as a drawing background or a drawing lines is that if you down the road, I know this might not ever happen with y'all, but with me it's like, oops, I mislooked at the size I needed, and so I can actually go right back to these boxed areas here in my base skeleton and change a value, and you get wider, taller, whatever. And the assembly of frames that I add to it will grow and coordinate with that box as well. So it's got twofold in that it gives me somewhere to draw, as well as it gives me something to flex so that I can try some different sizes and different angles, things like that, with my overall shape. Now, when you go to start laying this out, you'll hit Insert Frame. It'll come up with these various materials, frame members that are stored over in the Content Center. And, of course, you've got different standards to choose from. I'm very American, so I'm going to go with ANSI here. Your different shapes, pipe shape, square shape, rectangular shape, bars, etc., that you can choose from. And then, of course, your different sizes once you choose the shape that you're after. So whether it's an I-beam, an angle iron, whatever it is you're showing, you'll get your basic sizes there. And then coming on down, the material you want to use, your overall appearance. I've made this material yellow so it pops out of the screen, shows up nicely. You've got buttons running across the bottom. The main thing I recommend is prompt for file name. Turn that off. Let Inventor name it whatever it wants. And then the second one there is for the storage and how it's going to go in and be stored exactly inside of the folder structure of the project that you're in. And a few other buttons down there too as far as how you're going to select your line work. On the placement, you've got it by selecting an edge, okay, which is one reason why we have that skeleton in the background there. Otherwise, though, you can pick just between a couple of points and say, let me just insert it there. Of course, everything has an orientation or a justification that you think of in terms of text or orientation, where you could say center justify it, top point, top left, bottom left, etc., as well as some offsets and rotations can be applied to it as well. So you've got various ways of going in there and setting this in place. Now, what I'm thinking, generally when I'm laying out these boxes that I want to draw on or use as my background skeleton, is I think of everything that I'm starting to model right now that I'm kind of thinking I want it to stay within the box. So I want it the edges of the, in this case, the square, to stay inside the box. And so the orientation becomes pretty important. Now, there's a little bit of a trick with this. What I'm going to do is get one set. So I'll kind of go up here at an angle. Notice how it likes to highlight an edge as I move around. So I'll pick. Now, generally what I will do is look at that. I'm not exceptionally magic about being able to look at what justification point I've picked and know exactly where it's going to come in. So I always have to have the visual. And so I see that in this case, my member is on the outside. And so I'll just start changing my other corner points. Got it the first time. But as you move around, you see it moves its justification as I pick as well. And so at this point, I'm on the inside. And so I'm happy with that. Now, here is the trick when you go to place these things, is that if you will pick an associated point to the line that you just did, it will understand that you want it to stay in that justification. If I'd have gone out, for instance, right now and over here to this backside and picked that point, there's a good chance it won't come up inside of the box. It could very well be outside of the box. And so by doing it in a controlled method as you go around, you could save yourself a little bit of effort as far as having to rotate things around. And if anybody's ever done this, you know you'll get one in and then you'll get one that's rotated wrong and you'll say, no, I don't want that. You hit cancel and then you lose everything. And it's almost like starting over. So if you do it right, do it right the first time, then it's real easy to run around and get them all into place. Now, I'm looking at it. Looks like I've got all the parts in. By the way, you'll notice I kind of focus in on multi-select here, but you've got chain selection where it'll kind of run around a chain, or selecting a sketch. If you've got a more of an elaborate sketch laid out there, you can pull that out as well. So you've got some good tools here for doing this. I'm going to go ahead and hit apply. This is what I was talking about. It's going to create a new frame member, so it's just asking me where do I want to store it. Am I happy with the names and all like that? But some folks like to name these items. I'm kind of like, I guess maybe I'm lazy. I just like Inventor to just go ahead and name them himself. So I'll say OK to that. Let it think a moment. And there we go. It's all coming into place now. A little bit slow. I think it's because maybe projection slowing it down a little bit. But now at this point, you'll notice I've got a nice little box there. So I'm going to cancel out of this, and of course now's a good time to get rid of that background skeleton, so I'll turn the visibility off so we can see our box. Now I'm going to go ahead and hit save. Of course this is kind of some initial save stuff, so I'll say OK to that. At this point I could actually start doing an analysis on how much this box can, what kind of loads I might be thinking about placing on this box. Right up here on the Design tab, there's a frame analysis, and I'll just kind of show you here real quick. We'll say Create a Simulation. Now, in this case, you've got static and modal, which, of course, your modal would be more in line that if this box was going to house a motor, you could set the frequencies so that you'll know when the frame's going to start rattling based on the motor itself. Or static is more like where you're just going to put some loads on it and you want to see what the deviations might be. I'll say OK to that. It is kind of a, you'll notice it kind of went into another little environment right there as it set it up. And so you can see now that as you move in, what it's really looking at now are these green lines that are seen up at the screen. The model parts themselves at this point, you'll see they're kind of faded back, somewhat transparent, because the analysis has already projected what it refers to as its node points. And so it's projected those and it's connected them together. Another thing, or another reason why I like to go ahead and do it like this before you clean it, before you miter it, before you might do some trimming, is you'll start getting a lot of extra nodes that way. And to me, that just kind of confuses me more than it maybe confuses the program. But it confuses me, and sometimes it might make a node dominant that maybe I don't want to be dominant. Other thing to note is the down arrow here. In my case, it's pointing down. It depends on how the parts are modeled on what is down and what is up. And so, as is typical with Inventor, it thinks in terms of up and down on the y-axis rather than the z-axis. So if you had modeled this, for instance, with the z-axis being your up and down, you might have to actually, you can either select this, the arrow and right-click on it and edit its location, its up and down. See, mine's on Y. You could also upside down it if you wanted to, flip the load direction. But you might find yourself needing to play with that depending on how the assemblies come together and been brought together. Now, as far as different things going on up here in the simulate environment now, our tab, our panel up here is kind of rearranged a little bit. We can look at the individual beam properties if you wanted to change something about the beam properties now at this point, maybe change their material, things like that. You could. You've also, here's the material change. See, mine's on mild steel at this point, but again, like I said, you could customize that, change some of the properties, change some of the materials. On constraints, in the next panel here, we've got fixed, pinned, floating, and some custom constraints. The most important one here is the fixed constraint. Pinned might come into play as well. It's always very nice with inventors because it kind of, if you just let it sit there, it will pop up and kind of give you an idea of how to use that particular constraint there. And so then there's floating as well that'll kind of represent an area that might actually be moving along, so you can change the floating direction in custom. But fixed is basically saying here's the floor. Okay, you can't go down beyond the floor. All right. Hopefully you can't go down beyond the floor. Hopefully your building's made well enough to hold up. So when you go to say fixed, you're saying select origin. Now you can select anywhere along a line if you so choose, or you can select directly on a node, and that's to me the better place to do that. Now one thing y'all cannot see is that every time you place one, you exit the command, so I'm just hitting the space bar with my thumb, so it reissues the command. Otherwise, you're having to go back up to the ribbon and actually select it. So here again, I'll come in there and get my node, and kind of these pedestals are just icons that represent that particular point will not move. Okay, so since it's all tied together with the green line there, the idea is that none of this will actually move down here at the bottom now. Now, when it comes time, you've got a couple of three different ways of doing loads up here: force, continuous load, and then moments. Okay, axial movements, bending motions, things like that. A force is just a particular location of where you're going to put some weight on. Okay, it's kind of focused or concentrated in a single area. And of course I could change the offsets here, and then I can change the magnitude. Now to get the dialog box up, that for me is a little easier to read sometimes, if you just go ahead and say OK to the placement and then double click on it, you'll get the dialog box up. And so see angle, and then of the plane, and then 90 degrees, etc. on where it's going. My offset, so I could change that value now. Maybe I wanted it more to the left, more to the right, I could change. And then I could put a force on that point as well. So once you put a force on it, you say OK. And as far as your basic setups, now you're pretty much done. At this point now, all you need to do is go into simulate. And again, it kind of goes into this other little environment here. As it's generating the simulation of the deformation of what it sees is going to happen here. Now, when you do it this way, folks, oftentimes by default it exaggerates it here by kind of a factor of 1 or a factor of half, or you can go to the actual deformation. And so in this case, you'll see, well, it doesn't look quite so bad now that we see the actual. Yeah, there's a lot of stress right there. But you can exaggerate it by going up here and just say, give me a 1 there, so that you can actually get a little more visual on what's happening. So in this case, it's bowing down this front of the bar here, but it's also causing, by doing that, it's pulling in the tops a little bit, so it's causing some bowing here on the legs. And then as well, as a result, it kind of cascades back around and bows it out over here. So at this point, I could take some time to say, well, no, that deformation, my displacement here, that's maybe a little bit much. that I don't want it to go through, and so I might say, well, no, I'm going to have to go in there and put some strengthening areas in here. So you say finished. Then at this point now I could come back, turn back on my frame or my skeleton, my background skeleton, actually add a little bit more line work so that I could then go in there and fix it up so that it would hold up under the stresses. Now I'm going to go ahead and hit save here to this and say OK. Let me let this think a moment. And then I'm going to go ahead and close this back down now, and I'm going to go and open up an assembly, another assembly I've got. Now over here I've got a robotic support, kind of the idea of a robotic support here, okay, because we just drew this box frame here. It was asking me about updating that. Now in this case you'll notice I've added a little area to the top, and that is a totally different assembly. So your analysis will work just fine with multiple assemblies. You don't have to assemble it all in one place. Now I'm going to do a couple of things here real quickly here. I want to actually expand the frame down here and double click on it. And what I'm going to do is find those two kind of angled pieces there, and I'm going to hide them or turn their visibility off at this point. And so the first analysis that I'm going to run now on this particular assembly is on the cantilevered part or the overhang part there, and just show you how that's going to be done a little bit differently here as far as the result it's going to actually give us as well. Now, a few things here back to the design. Now, just to give you a quick idea on how I modeled this part, if I actually let me go back up here and do that and right click and just open it up separately. Here's the part as it was modeled. I will turn the skeleton back on so that you can see how that was actually laid out. And so here once again I used the edges of the solids and again stayed inside of the boxes. So I stayed inside the box so that these things could be shipped separately and assembled on the field. And the main difference that with this one is the individual just sketch lines. You might can see the blue in there showing up very nicely, running down that outside top corner of the cantilevered part of the line. So there I laid that one out using that particular line rather than part of the actual solid. So you can just sketch in line work as well and then connect to that. Oftentimes, for instance, when I'm helping folks lay out skids for the first time, we'll just be using line work there to represent the edges of these skids outside and then the inside different angles inside there for the supports of the skid. And so we'll lay it out with just line work and not have any solid mechanism in there, no solid bodies like I've got here. Solid bodies come in handy though for being able to get multiple edges, especially when they're kind of mirrored over and symmetries going on and all like that. But notice here once again, I've not cleaned up anything. Once again, all of this is unclean at this point. All right, so let me close this out. I'm not going to save it. It's already fine the way it is. And here I've got now a skeleton showing up here, so let me hide it. There we go. So now we can see our assembly. Now, again, like I said, I've got two assemblies here now. Now, at this point, what I'm thinking is on this angle side might be a housing mount for either more structural members, more machinery, robotics, various things like that could be mounted on that angle. So now I need to do an analysis of that. Now, because we're in a separate assembly file now at this point, y'all, I've got to pretty much go through the frame analysis setup again. So you see as I, whoops, and it looks like, let me say finished on that real quick. It looks like y'all caught me where I was testing a few things here. So let me just kind of quickly say create a new one. to overwrite that one, you'll see we've got a static analysis and then the modal analysis here. And so I'm going to just say OK again, and what this do, we'll go through the setup once again. So it's as if I had not done an analysis. Now, notice here again, the fixed points that I had originally on the base bottom down here did not come back over. But a few things you will notice here, just by the way it's laid out, you kind of look inside there, you get a lot more going on with the node points now, the way they're laid out, and then you get this nice one there. You can, and I don't know if it's easy to see, this line right here, what that does, that signifies a rigid connection there. And so since it saw that those points were kind of straight up above one another, it defined them as a rigid connection. Basically, think of them as almost like they're one. They're tied together. They're not going to go anywhere, okay, without the other one being affected as well. And so the program actually looks for those types of connections. You'll see it up here where I've got actually a little bit of cleanup here that I did. And so it projected these 2 points to make a rigid connection there as well. And so again, as we just move on around, you'll see here where I didn't do any cleanup, it gave me just a single point. So it will, if you do the cleanup, it will try to project where those rigid connections are, but sometimes it actually projects them off at an angle, and I find myself needing to say, well, no, that's not exactly what I want, and so I might have to actually delete that rigid connection or rigid link, and then you can come back up here into your ribbon and put your own rigid links in. So you actually select the 2 nodes, and it becomes, you're putting your own rigid link in at that point. All right. Now, once again, my up-down arrow is in the right location because I modeled this thinking like Inventor does, where the y-axis is up and down. And so I still need to go through that part of fixing the locations down here. Now, like I said, I could pick like out here somewhere and make that a rigid connection right out there and change the offset back and forth. So, for instance, if you had footings underneath that, it might be that you might want a rigid connection right there, as well as maybe over, if you have footings under the corner, you might be actually putting in rigid connections or fixed points, I mean, at certain locations under the bar. In my case, with the way I modeled this box, the whole thing's sitting down on the floor. So I don't need to necessarily do it that way. So again, back to my button fixed point, I'll grab the node there, place it, and then come right on around with my spacebar hitting enter instead of going back to the interface. Whoops, now that one I missed, so I'm going to go right back at it. It's easier to delete it than to try to move it into place. And then come up, I did it again. And I'll get it this time. Now let me zoom in. Sometimes it's easier to zoom a little bit. Sometimes it fights me. If it fights you a little bit, just turn your screen and come at it a little different angle. It makes it a little easier to hit if it doesn't see anything else there. So now I've got those points affixed. So they're not going to move, and they know where the floor is. Now, in this case, I'm thinking of maybe some sort of torquing type of robot arm that might be putting a lot of stress down on the cantilever or the overhang part here. So as far as my load goes, instead of a single point of force, in this case maybe I'm going to put a continuous load. And here's another reason why I like to do it before I clean it. When I select this line here, it's going to extend it all the way down. Otherwise, if I had trimmed this part back, the line would stop right there. And so it would think that I was putting all of the force just on that one piece rather than maybe being shared across the angle arms coming down. Of course, that does imply a little bit of how I'm thinking in terms of cleaning this up once the time comes. So when I select that, it lays the icons on there. Now, if you're wondering, all these icon colors and all are completely customizable. So you can change the way they're looking. I'll just go ahead and put about 150 pounds on that. So in your frame analysis settings button up here, this is where you can get in and change the color of the loads. So you see there's this kind of yellow color there. So there's that. The constraint, remember my points down here went to this gray color. So there's the constraints, gray color. The yellow, again, gravity is up and down as well, and it's the same color yellow, and the nodes are blue. So if you wanted to, you could go in there and change those colors if they made more sense to you. Maybe from a previous life you might have done this with a different package, so you could get in there and change the colors if you wanted to. Got a few other settings that you could look at too on creating the rigid links. Some people don't want it to. They want to add them in themselves. But I personally, I'm one of those kind that say, well, let Inventor do it. As far as the original model, I like the transparent. I kind of like seeing where everything is, but some folks prefer the invisible. Just turn it off completely so I can see what I'm doing better. Of course, some settings here on the solver as far as how it's going to generate the points, and then a little bit of settings that you can do here on the colors of the diagrams that are actually created in this process as well. In my case, I'm kind of happy with the way they all are. Now, I generally find myself getting the loads put in first thing, and then come back and double click on them. And this way you see I get the dialog box up. Now, depending on how you're wanting this to actually work, with this particular load like so, maybe I'm thinking, well, over there on the far side, it might need more magnitude of weight, and so you can actually click the box here on the end magnitude, and maybe on the beginning or start, I could drop it down to 50. So you see how the icon will then show, okay, I'm putting more stress, more weight on this corner versus the other corner over on the far side. If you're happy with them both being the same, there we go. We just do it like so, and we're good to go. Now, the other thing that you can do is these two little icons here will change the orientation of the stress that's being applied. So if I come up and grab the top, you'll see I can rotate it along so that I can get it perpendicular or normal to the slope rather than it being straight down on it. It's a little bit more normal now at this point. All right, I'm going to say okay to that. Again, I'm kind of happy with that. A few other things just to note up here in the display up here in our ribbon is the idea of being able to assign your own nodes. So if you know there's going to be other stresses in other areas, you could assign your own nodes and make rigid links between those nodes then. Okay, these two, being able to do custom nodes and rigid links, very important, particularly when you're doing building and housing. Particularly, I'm thinking in terms of roofing, where you know the stresses, how they're going to be passed down a certain member. Then you can tie those two together to keep them rigid together. Now, at this point, I think we're pretty good to go. So I'm going to say simulate. Now, remember, I turned off a couple of members of the particular support here on the top part, particularly off of the angled area. And so you see they were not generated. Because they were turned off in the model, they were not generated, they were not analyzed in this. And so as I come back around now and we take a peek at it, we can see what the stresses are. And notice how it passes right on through to the other assembly. Okay? So even though that was a separate assembly, where we actually did an analysis on it earlier at a fixed point, it does understand that in this particular mode, in this particular assembly file, they are attached together, and so those stresses are passed right on down. And so you can see what's happening here is the stresses are starting to affect our lower assembly as well. Okay? So here again, we can start taking a look and playing around with our various values here to see what is going to happen. Now, here again, I'm looking over here at my stresses. based on my displacement. My displacement is in inches, so it's 0.03. If that's good, if you're happy with that, then you could say this cantilevered out extension is just fine, and then you could move on. If you're not good with it, you say, well, no, we can't even have that much. It's a very delicate, fine process that the robot's doing, so we can't have it deflecting 30 thousandths of an inch, or we need it to actually be less than that. So what we would need to do then at that point is add in some more support. So we can now start refining the actual assembly that we've got here before, and again, emphasizing, before we've done any cleanup on the frame members. So once we come out of that, and now at this point, I will go in back over here into my browser area, and I'll turn those two back on. So right-click, make them visible. Okay, so now I've got the first one back on, and then the second one, visibility, we're turning it back on now. Now, one way, again, just to kind of come back and talk about that real quick, what I did there back in the overall assembly, I'll right-click here and open it. This was a case of where I didn't actually have my solid showing up there. Let me go up here and turn it back on real quick so that y'all can see what I'm talking about. I didn't actually have the solid drawn there. So when I went to use my insert frame, the option that I chose to put those in there were point to point. This is another one of your options here, insert the members between points. And so I was able to easily find a point right up there where this cantilevered line was lined down. And then again, right back down here to the corner point of my solids. All right, so again, I had two good points to work with there. Of course, then did have to play around with the orientation to get it oriented in there in the way that I wanted. So now I've got those turned back in, or turned back on. So let me turn that visibility back off there. And actually, I didn't really need, I'll say no. And so now we're back over here. Let me write, let's see, one of my visibilities is on here. It might be under my, hold on, let me find it. That one's off, and that one's off. Wow, that's interesting. Let me right-click. Sometimes turning them on, oh, it was the display representation. Let me turn that back off now and update. There we go. So now we can see the assembly a little better. Now, once you make a change like that, all you have to do is go back in and hit frame analysis. It understands that you've done it once already, okay? But I have made a change, so I need it to recognize that change, and so all I need to do is go up here, instead of saying create a simulation and start all over, there's an update button. So I'll hit the update button, let it run through its thing there, and so now you can see that there's a few extra, there's actually an extra node alignment there put into place for the vertical. Notice it's a little off though. And that's because of the placement, the angle it's coming up at. The node's a little bit different. But once again, Inventor looked at it and said, okay, those should be rigidly attached. So even though they were not on top of each other, it tied them together as if they were. All right? So now I won't make any other changes at this point. And so now I'll do my simulate. We'll let it run here. And then we'll take a look at the response that we get. All right, so now where it was a 0.03, now it's a 0.01. As far as my deflection, maybe that one I can live with. If not, then I might need to go in there and work with the way I'm supporting it a little bit more until I get something that I'm actually happy with. Now, at this point in the results section of the browser over here to the left, It usually will always default to the displacement, so that's what we're seeing here laid out. Again, over in the analysis setup, you can change the color bar. If you don't like the way the color bar is laid out, you can actually go in there and change it. I think you can hit it right here as well. You can see, you can get right to the color bar. Make changes to the color if you so choose. You've also got a few of the other reports that are showing up that as you double click them, it regenerates the view. So I could look at the forces in the X specifically or forces in the Z specifically just to see what is going on specifically in areas. And so as a, okay, there's one that kind of surprised me a little bit, but okay, that's, oh, that's in the Y. All right, that's the up, well, the up and down. That kind of makes me wonder why it's a little harder over there than over there. But again, you can toggle around and take a look at those forces and see how they're being applied. You've got the moments as well, and so as you notice that as I double click them and activate them with the little checkbox, the picture updates over on the right-hand side so that you can see exactly where those forces are having the biggest impact. Of course, in the Y's and in the Z's again, so you can see the Z's really having a lot of force right here. Okay, I'm not certain what's going on over there. I'd have to go back over there and look at how it laid in the nodes. You've got normal stresses as well, so that you can look at that just to see exactly where the stresses are going to be laid in. On and on it goes. So you've got excuse me, various forms over here that you can of the results that you can take a look at and see what's going on. Now, a few other things that you've got that your capabilities with this is once you get the analysis maybe in a mode that you like. This is actually a little more fun if I adjust it, really exaggerate the stress and the movement. You can actually animate it if you're so inclined, so I could sit there and show it, over-exaggerate what is happening to the overall frame based on the loads that are actually applied to it. And if you so choose, you can actually save that out as an animation and include it as maybe a package inside of a zip for sending it out to the client, the engineers, etc., as far as what where you might want to be sending out the report. So you can do a quick little animation on it. You've got a few other items up here as well as far as the report. Now, the report generation will allow you to send it out kind of an accumulative report in an HTML format. So once you generate it, you can send that out to anybody that's got like a Internet Explorer, be it Google or Foxfire or any of those that read it. You'll be able to, they'll be able to open up the HTML and actually see it. Now, I'm looking here real quick to see where mine's going, just to make sure I know it's going into my frame analysis area. So I'll say OK with that. It does kind of take over your screen. You'll notice it's putting some labeling in there as well. Beam labels, node labels are up here in the ribbon, so you can set those up as well for your reporting, and it should be done here shortly. And one few more, bam, 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 and boom. Well, I thought it was done. It's got a few more to go here. So here again, it's generating all of these automatically based on the results diagrams that you've got over in the left in your browser area. Okay. Whoops. Nope. Okay. Well, we're down to the shear stresses now. I thought this would go a little faster. And now we are into forces, moments, normal. Seems to be going around in some circles here. Let's let it just finish running. Should be through shortly. Okay. All right. Well, this is where I run out of things to talk about while we're waiting. I didn't realize it was going to take quite this long, y'all. Let's give it another few seconds here. So be prepared when you hit this
Tell you what, Dennis.
this report that you need to be ready to go to a break or take a lunch. Go ahead.
I did have one question that did come through. If you want to answer that real quick.
Okay, good timing.
It was kind of asked towards the beginning of your presentation. Somebody asked, how would I know if a member has yielded or failed? And that came from Randall Brown.
Yielded or failed? Well, first off, one thing that you've got when you're working inside of the frame generator is there is and I can't show it because this is running and I feel like I might be stuck in a circle here or something. Oh, no, it looks like it's coming back. It's got something in there that will actually check to see if everything's cleaned up, so that's nice. But as far as a member failing, that would show up in the analysis. So again, you would have, you know, heightened redness in that area if it was failing. It doesn't actually. Let's put it this way. Let's say you had a noticeable bend in a part. It will not break the part. The analysis does, in and of itself at this point does not go as far as to say, okay, it's broke right here. So that part, that's where you as the engineer are just going to have to look at what the analysis, what it would show is a very acute bend, okay? But it wouldn't necessarily go broke, okay? So you would look at it at that point and use your engineering expertise and say, well, okay, the analysis showing it as a bend, but I know it will really break right there, okay? So it doesn't actually snap the piece, okay? Now, y'all saw that all bouncing around there, so let me jump back over here into my folder. If you wanted to talk about that, by the way, a little bit more, just let me know, and I can dig into it a little bit more. But that's, yeah, it's not going to actually snap the part. It's just going to really bend it, even to a point where I think you visually would be able to look at it and say, okay, I know it's not going to bend that much. All right, right here is the report. So you see it is an HTML format. And so as we just kind of scroll down here, you see it's all rolled out, giving you all the various information, and then the pictures that go along with it nicely. So you can work your way right on down that report. And then, well, let's see, did I double click it? I must have probably did. Right click, open. Does it come up? Yeah, there we go, just the one. Okay, so again, there's your report that comes out with it. By the way, this report can be customized as well, so if you'd rather have your logo there rather than Autodesk's, you can do that. Okay, so now, of course, there's that analysis there as far as the report that comes out. You can also export it out if you wanted to take the simulation out and put it into some other package. You can take it out that way as well. And then, of course, then once I say, I was just looking a few other things, some beam details, where I could go in here and say, select a particular beam, say, give me a little bit more information on that particular beam and what's going on with it, so you can get some detailed information in there as well as a diagrammal information, okay, of what maybe is showing up over here in the browser. So with that, then we've got that one figured out. We can see where maybe we might need to make some changes or not make have to actually maybe add some reports. Now, if I say open here again, I'll just kind of do this one real quick here, y'all. I wanted to kind of go all the way through here to show you where you might actually even say maybe utilizing some of my existing structural pieces there. You again various sub-assemblies here. So once again, I could jump right into my frame analysis here at this point, and then with my continuous loads. Whoops. Okay. Timeout. Finish. I got to get in there and actually create the assembly. Frame assembly. create it based on the given geometry that's in there right now. Let that think a moment. So now, a lot of extra nodes now, okay, which could start giving you some headaches. I have had at times go in there and figure out where rigid nodes were selected and put together that shouldn't have been. But here in this case, I'll do a continuous load layout. Let me kind of rotate it around. And this time, I might want it to actually run it right on along, along multiple sides, okay? So we'll say okay to that one. And come in here and try to find a good line, like right about there. I tell it what I want there, though. There we go. So again, a little bit more of loads going on. Time out. There we go. And check that. And I'll come on around and put some more load over here on the back side just to really weigh this thing down. Okay, so now I've placed loads all up there. Okay, and so again, I'm thinking in terms of this might be more like a building structure, or possibly you know, inside of a warehouse structure for a walkway, or even structure for a moving assembly of maybe a moving lift or something to that effect. And then once again, do my simulate. No constraints defined. Yes, I forgot to put the fixed points in there. I should have left that open as a question. Let's see if I can just quickly get those in there. There we go. And if you really wanted to have some fun, don't do it with a, just do one side and you'll see the whole thing kind of bow over. All right, now we're ready to do our simulation here, see if it would hold up under the weight that we know is going to be placed overall on the top frame. And so, yeah, now this is a kind of a good example here of the type of message that you will get back at times. What it's saying is that there are certain nodes in there that it just doesn't like the way they're tied together. So that takes a little bit of time sometimes going through and figuring out what node, as well as then correcting it, because yeah, it didn't quite tie the rigidness of those particular nodes together. So I'll say cancel on that, though. It doesn't necessarily stop the program, doesn't necessarily negate the results. It's just saying that, hey, in my case, there was a couple of nodes it wasn't really happy with. A couple of nodes I might not worry with that much, because overall I'm looking like, yeah, I'm getting the type of symmetry that I would expect to see. And so here again, I can also exaggerate it a little bit so that we can see exactly what's going on. And so now at this point, I know that in my design, I might need to go in there and put a couple of verticals in just to hold that in place. I'm getting a 0.4 deviation at the worst point, and so that if that meets my tolerance, then I'm fine. If not, then I need to go back in there and straighten it out. All right, so as far as kind of an overview there of a little bit of the frame generator as well as the analysis capabilities that goes along with it, that's about all that I wanted to show you. Looking at the time, it looks like it was a good, I planned that just about right. So at this point, let's come back up. If there are any more questions, now would be a good time to put them out there.
The question pane is on the right-hand side of the screen if anybody has one. I guess we'll wait about another minute before we progress. I have one from John Gray. Dennis, he asks, can you customize the report export and
Yes.
minimize the results?
You can. It has I think what kind of generated more there was when I went through there and did a bunch of check boxes. And so it generated those and then added them into the report because I know I did that earlier when I was just running through my practice session, and I didn't check all of those. I just thought to myself, well, I'll show them, and then it didn't generate all those. So yeah, if you don't check them over there in the browser area and get it to generate at one time, I don't believe it then exports them out. You've got a little bit of tweaking that you can do on the export, but primarily it's an HTML file. So with something like Notepad XML, you could actually go in there and edit it after the fact as well. So you've got a couple of different avenues for customizing that report.
Perfect. So I think we'll have it there. Thank you, Dennis, for presenting today. Just to kind of recap, if you guys haven't already, search our Live Lab Learning on Facebook and like our page to receive the latest information and special offers. When you visit our website, livelablearning.com, there's a complete schedule of upcoming training and future informational webinars and software updates. Well, thank you again for, oh, I'm sorry, I had another one come in late there, Dennis.
Okay.
We have a class on stress analysis. Do you know if we have one of those coming up?
I don't have the schedule right in front of me, but we do. We do offer a class on the, it's an overall class. It's a simulation class. And I'm groping right now in my memory for the name of the two books that we actually recommend for the class to coincide with it. They're not your regular Ascent type books. It was a particular books, and I can't remember now what the names of them are. But Jason Miles and myself both have taught that class.
Very good. But yeah, thank you for joining us today. We hope you found this information important and really more so than anything help your business. We look forward to you joining us on the next webinar on the 14th of April at 12:30. That is the Get It Right the First Time simulation. Other than that, everyone have a great day, and we will see you in the next one.